Hello, my name is Mark Gibson, and you're listening to the podcast version of the Teagasc Signpost Series, a weekly webinar that promotes and examines sustainability in Irish farming.
You're very welcome to this week's episode of the Signpost webinar series. My name is Cian Condon. I'm an Outreach and Innovation Specialist with Teagasc and coordinator of this Signpost series. I'm joined this morning by Dr. Patrick Forrestal, Senior Research Officer with Teagasc, based in Johnstown Castle. And Patrick will be covering reducing emissions from nitrogen fertiliser while sustaining or improving production. And given both the time of year and the situation we find ourselves in the world at the moment, it's proven very timely indeed. I'm also joined by Mark Plunkett, and Mark is Signpost Training and Development Specialist, and Mark will be helping out with questions this morning. Lots of very important information to be covered, Patrick, so I'll let you go ahead. Thank you very much.
Thanks very much, Cian, and it's a pleasure to be here this morning. So look at this morning, we're going to take some time to talk about reducing emissions from nitrogen fertiliser while aiming to sustain or indeed increase the levels of yield. And I suppose the pressures that we see in the global markets have put upward pressure on nitrogen fertiliser prices, and I suppose even some question marks around what will be the availability side of things. I suppose hopefully that will settle down, but we have to recognise that I suppose this is the world that we live in, and it's not for the first time in the last number of years that we've been talking about substantial fertiliser price increases or availability concerns. So I suppose it's against this backdrop that I'll talk this morning. And so look at, I suppose over the course of the next hour, we've got time to, I suppose, talk through these areas and take some questions on them. But I suppose in terms of sustaining our levels of production, nitrogen fertiliser is an important part of that puzzle. But those, I suppose, cost and supply challenges that we're seeing now recur is a backdrop that's there. So we can't lose sight of some of the basics around getting the most out of the nitrogen fertiliser that we do use, but also reducing our reliance on that nitrogen fertiliser. There's potential to displace some of that reliance using clover. Can we get more out of the organic manures that we have, particularly the slurry? Over the course of the next month, a lot of slurry is going to go out around the country. So we'll talk a little bit on that topic, and how much N is there to play for? Can we tap into that and to retain more of it? And then we'll get into some of the nitty gritty of fertilizer type, different options. I suppose, what are their pros and cons? What options does that provide in terms of reducing emissions for a given amount of fertilizer that's applied, and also some really new results from work that we did last year, looking at blends with phosphorus. Can we see protection extended into those type of blends? And then also on the liquid nitrogen side, what's going on there? And nitrification inhibitors, another inhibitor that offers potential to reduce emissions. So look, I suppose starting off with pH, do you know the pH of each field on your farm? Now's a really good time to be, thinking, right, if I don't have already soil samples, can I take some, or can I dig out the last soil sample results that I have? Chances are the pH isn't going up since those last soil sample results were taken. And I suppose the insight that we have from the analysis of the 2025 national soil samples that came in to Teagasc was that about 44% of soils were below a target pH of 6.2. So that means that, while that did mark an improvement on the previous year, it does mean that, at least 44% of soils, they're not in the best place to make the most out of the nitrogen that is applied. And indeed, nutrients like phosphorus, which we have now seen increase very markedly by as much as a euro a kilogram, going up in price, are going to be locked up and not as available. So, really, can you at this point say, right, can I identify some fields that need clover, or that need lime applied, and line up some lime, get it out, get it on the farm and get it out here where you can get the most benefit from it at the start of the year. And that's really going to set you up to make the most out of the nitrogen that you apply. And also, we know that it will also release phosphorus. So, potential there to, make some savings on fertilizer costs, and also get more out of what you are using, and I suppose release nutrients that are there in your own soil. So I suppose we see nitrogen prices going up and fertilizer prices going up. Lime is, even more so better value than ever, I suppose, in this context. I suppose there are some, particular issues, soils that have high levels of molybdenum. You don't want to go above 6.2, and then for peat soils, the target is 5.5. But for your productive mineral grassland soils, particularly if you're trying to get clover in, you want to be targeting a higher level of pH, 6.3, 6.5, at a minimum to be in the best place. And we know that this can also have an impact on reducing emissions. So you're also kind of have this co-benefit of mitigating nitrous oxide emissions by increasing the soil pH. So we see here in some trial work that was done at Johnstown Castle, as the soil pH increased, we see the emissions of nitrous oxide from fertilized grassland reducing. Okay, so there's a co-benefit there in terms of reducing nitrous oxide emissions, which is also linked to good nitrogen use efficiency of the applied nitrogen. And I suppose that ties in quite well as well with trying to bring clover into our swards. So we've seen a lot of headlines around nitrogen fertilizer prices and fertilizer prices in general increasing. For farmers that are set up to grow a certain amount of their own nitrogen on their own farm, which is essentially, you might hear this term bioeconomy. So this is in the bioeconomy, you're essentially growing that nitrogen on your own farm. So, you're not reliant on a fertilizer plant somewhere. And I suppose one thing we can say about that nitrogen that is set up to be fixed is, the price of it didn't increase. So whatever nitrogen you're going to fix with clover this year, the price of that stayed the same. Now the value of it increased, and that's money in your own pocket if you can, grow more of your own nitrogen on farm and lessen your reliance on chemical or mineral imported fertilizer. So I suppose what we see here linking to the pH is that as the soil pH increased in this trial where we direct drilled grass clover sward into a burnt off setting where we had different pH blocks, as the soil pH increased, we saw better success with the clover and higher levels of yield achieved, which is a reflection of the clover doing better and fixing more nitrogen. And we know from work published by Cashman and Humphreys last year that if we look at a setting where you compare grass clover with can here in the center, this had the highest levels of emission. A grass with zero fertilizer nitrogen had much lower emissions, as you'd expect. Obviously, there's going to be a substantial yield penalty there. But in the setting where they had a grass clover sward that got zero fertilizer, they had much lower nitrous oxide emissions, and they had yield levels that were, they were a little bit behind the fertilized pasture, but they were much closer to it than the zero fertilizer, obviously. So I suppose the tip here is that, even where you can partially displace fertilizer and nitrogen with clover, this can help to reduce nitrous oxide emissions. And liming, again, it goes back to liming being part of that picture. So I mentioned about, I suppose, the whole slurry side of the picture at the beginning. Like over the next month, we're going to see a lot of slurry going out for silage ground. This is a really, I suppose, valuable resource that we have on farms. But I suppose one of the issues in the manure management chain is that we can have substantial losses of that nitrogen, which is essentially part of your fertilizer allowance on the farm. So the more of it you can hang on to, the more that allowance you actually keep onto to grow grass. If we look at the EPA estimates of ammonia loss nationally, that translates into over 100,000 tons of N. So that's, roughly speaking, equivalent to maybe around a third, plus or minus, of the equivalent to around a third of the fertilizer nitrogen amount that we're using. So that's that gives you a kind of sense of how much nitrogen is there to play for. So the more we can kind of eat into retaining that nitrogen and using it on farm, it lessens our, I suppose, reliance on the imported fertilizer. And that's more important than ever in this particular year. Now, we're not going to retain it all with low emission slurry spreading, but I suppose as that slurry is going out this spring and over the next month, using the low emission slurry spreading is, I suppose, more important and more valuable than ever as we see the prices of fertilizer nitrogen increase. And I suppose this has other implications as well, because it indirectly contributes to greenhouse gas emissions, and where that ammonia, I suppose, blows away, it lands elsewhere in the landscape and it becomes a nitrogen load on the overall landscape, although maybe not growing nitrogen, not growing a crop in your field. And that has implications also for water quality, as well as sensitive ecosystems. So I suppose there are many benefits to retaining that nitrogen on farm, and it can also help us, to deal with an environment where perhaps the, I suppose, total nitrogen allowances are being squeezed. And I suppose part of that picture of setting ourselves up for success with the nitrogen that we do apply, relates also to optimizing P and K and sulfur. And we'll talk a little bit about protected urea and nitrogen fertilizers, and there are options there to deliver P, K, and S in this space that we'll talk about. We know from trial work that's been done at Johnstown Castle that optimizing phosphorus supply is also associated with reducing nitrous oxide emissions. So there's a co-benefit there. And I think you can see here in this particular picture where we've got an NPK program versus an NPKS program, you can see that visual difference there: increased yield, increased nitrogen use efficiency. And as we're on the cusp of thinking of applying nutrients for silage, it's important not to forget about sulfur in the in the silage program. And pretty much all the silage ground, whether it's getting slurry or not, should get some sulfur, would be the recommendation. Okay, so I suppose to get into the nitty-gritty of fertilizer forms, which is maybe what you were expecting to see fully for this presentation, and we will do that. I suppose the forms of nitrogen that are used are urea, ammonium, and nitrate. So the options that are out there tend to be either one or a combination of these. And I suppose traditionally we've been very much a granular solid fertilizer market, but every year I've seen more questions coming around liquid fertilizers, for example, urea ammonium nitrate, which is a combination of urea, ammonium, and nitrate. So that's a liquid fertilizer. And we've got some work coming through on that. There's also more questions about, dissolving urea and foliar feeding, and there's much less work done in that area, but hopefully that will, I suppose, there'll be more information in that space as time goes on. And I suppose before we get into, some of the results, just to kind of take us through a little bit more technical detail, and I don't want to lose people, but if you think about, urea based fertilizers, that's all tend to be all urea for your 46% product. And then CAN is a combination of ammonium and nitrate. I suppose there would be a perception that plants have to wait around until nitrate is available to actually take up nitrogen in that form. And certainly plants can luxury accumulate nitrate, and they may even preferentially take up some nitrate. But once they've got ammonium available, they're also taking up ammonium, and that is plant available. Plants can also take up a small amount of urea, but that tends not to hang around very long, because through the action of urease, you've got this conversion over to ammonium. And I suppose that's the key risk around urea, that you can lose some of that nitrogen away as ammonia. And if you're losing it as ammonia, then you can't be confident that you're going to have a yield that's going to match a CAN product. And you're losing it out of your system. And that's where, I suppose the protection comes in. And we've done a lot of work, both field trials and reviewing all available field trial evidence from around the world, which has given us confidence to, recommend NBPT and the combination of NBPT and NPPT and 2-NPT, to protect from this from this loss. And then I suppose once you arrive at ammonium, there's this process of nitrification happening where ammonium is converting over to nitrate. And you can have loss of this greenhouse gas nitrous oxide both during nitrification and also when you've got a lot of nitrate in the soils under denitrifying conditions. This is where you have wetter, damper grassland soils, and our soils tend to be conducive to this particular loss pathway. And also where you've got nitrate sitting there, it's vulnerable to leaching loss, which has obviously implications for water quality, which we're trying to do everything we can to limit the amount of nitrate getting into water courses. As part of current work on our Department of Agriculture project, we're looking at the use of nitrification inhibitors as a potential tool here to reduce some of these losses. And I'll share some of those results as we come along. So I suppose just to kind of go back to brass tacks with the initial work that was done showed us that, comparing to using calcium ammonium nitrate, urea-based fertilizers had, much lower nitrous oxide emissions in Irish grassland. We've talked about how urea loses ammonia, so that's not favoured, and you have potential to fall behind in yield if you don't have that protection of NBPT. So, I suppose a simple change on farm, a relatively simple change on farm of substituting one fertilizer for the other, reducing the emission factor by about 70%. But I suppose the question has been there recurring, is there an impact on yield of making these types of changes? From the work that we did initially in cutting trials at 3 sites over 2 years, so that would have been 30 separate side-by-side applications to test this out. What we saw across a range of rates was that urea protected with NBPT, consistently matched CAN. So it sat right on top of it in terms of its yield performance across a range of rates. Now, I suppose the eagle-eyed amongst you might notice that we had some quite high rates here, and I suppose this was to test, the highest kind of application scenarios. And also bear in mind that these are cutting trials, so you didn't have that, 200, 250, maybe more kilograms of organic nitrogen recycling to the soil purely under a cutting setting. And I suppose what we did get some insight into here was urea was tending to lag behind at these higher rates, the standard unprotected urea, but the protected urea was, consistently matching CAN. Anya Murray, as part of her PhD and with colleagues in Teagasc, did some really nice work under a grazing setting across 3 years and 4 sites, 2 N rates. So we look at the 150 kilo per hectare here first. So here's the 0N. The urea fertilized plots grew about 12 ton. So, was there a benefit for CAN? Yes. Look, I suppose the trend was positive in that there was an extra 340 kilos. And the question is then, did the NBPT protected urea, match that, or was it back with CAN? And indeed it did. It was at least as good as CAN, even a little bit ahead of it. And what about at the higher application rate of 250 kilos? So here, the overall yields were higher. So urea grew 14 tons, and calcium ammonium nitrate, 440 kilos extra. So heading on for half a ton extra with CAN. So you can see a gap opening up between urea and CAN. So now we really want to see, will the urea protected with NBPT do the business and, keep you up there with CAN? And indeed it did, an extra 450 kilos. So, I suppose we again see, this consistent trend of, NBPT protected urea. It's not letting the nitrogen blow away as ammonia. It's keeping it there to match CAN. So I suppose just to summarize, what does this kind of mean from a practical perspective and, products that are available to farmers? All the major fertilizer suppliers are in this space with options in the NBPT or NBPT plus NPPT or 2-NPT space. And I suppose to date, the macronutrient options have been limited to, your straight N products, your 46% N protected, your N plus N S typically around 38%, and then also N plus K plus S. And we haven't had these with phosphorus available because there was a recognized, up until very recently, because there was a recognized issue there around the acidity in the phosphorus fertilizer degrading the NBPT. And that was the case for, for many years. But it was always the case that, technology would move on, new solutions might be found. And that appears to be the case now. So I'll share some insights into some, very fresh work that my colleague Temba has been doing as part of this Department of Agriculture funded project that we have, and that's been testing, I suppose, a whole range of options, including nitrification inhibitors and different formulations of fertilizer for their performance to reduce emissions. But I suppose specifically from this work, I'm going to focus on some options that have been in the market. So last year, we had, this Glaze NBPT protected Pro range of fertilizers, including, a 27, 2.5, 5 plus S option in that space. So bringing phosphorus into a protected urea with NBPT blend. So we did some testing on that. This is the system of wind tunnels that we can use to give a comparison between a whole range of different fertilizers in the same setting, in a replicated setting. We also looked at liquid urea ammonium nitrate, and again, that's in the market. Farmers are using it. You've got Omex there with options in that space. Also, farmers are using this acidified amide liquid nitrogen in some regions. So you've got a Flex product in the southeast and this NXT product down around Tipperary and in that region. So these are all, I suppose, options that are out there being used by farmers, but we haven't had a lot of information about them to date. So I suppose to start off with, on the phosphorus option side, containing, specifically this Glaze NBPT formulation of a protected NPKS urea-based blend. So the results of this work that we did last year have been written up. So they're currently undergoing peer review, and that process will, follow its course. But hopefully that work will be coming through published during the year. But to share some of the insights that we gained there, those were that the results show that Glaze NBPT used at 660 ppm in that formulation of a NPKS 27s blend was highly effective in protecting ammonia loss, and we saw comparable levels of reduction or protection as to what we've seen previously for straight NBPT options in previous trials. So that looks really positive in terms of unlocking a protected option that can deliver phosphorus out there, and that is in the market at present. So I suppose just to kind of, flag that work has been done, and the paper is under review. I suppose similarly, we've done testing of liquid UAN and also of this flex acidified amide nitrogen in 2025. Again, that's under review. Temba's paper is currently under review. And the results show that, I suppose, specifically for the liquid urea ammonium nitrate, that had much lower ammonia loss compared to granular urea. So its levels of ammonia loss, or its mitigation of ammonia loss comparing to granular urea, were very similar to standard protected urea products. So much closer to that level of protection than to standard urea. So that looks really positive for that perspective. And you can also add NBPT type protection to liquid nitrogen to get it even lower. So that's also possible. But even without that protection, still quite low levels of ammonia loss. And then we also looked at this acidified amide liquid nitrogen, and this was highly effective in protecting against ammonia loss. And we saw comparable loss reduction levels, again, to those seen with the straight NBPT urea products in previous trials. So again, that looks positive as, I suppose, another option. And, at the moment with, squeezes in availability and price and so on and so forth, I think it's positive that we have a number of options and expanding options in this space to reduce emissions. And I suppose the reality is that these products are being used out there in practice by farmers already. So I suppose sharing some of the results that we have published from this Department of Agriculture funded project. So this work is already published, where we looked at I suppose focusing in on times when we expected, denitrification to be a dominant loss case. So conditions where we know we need to mitigate loss. So what we saw was the emissions were the highest for calcium ammonium nitrate. So that would be higher than the average emission factor under these conditions. Obviously, urea was lower, but if we look at the flex acidified liquid nitrogen, that had very low emissions, similar to urea, and the liquid urea ammonium nitrate also had much reduced nitrous oxide emissions compared to CAN. But obviously, that's not the full story. We have some yield information that gives us some insight. And what we saw was that comparing to standard urea, a little bit like Anya Murray's grazing trials, we saw that CAN gave a greater level of yield than standard urea, right? Because you're not losing that ammonia. But also the liquid nitrogen products, they were similar to CAN in terms of their yield, and also better than standard urea, while reducing greenhouse gas emissions. Okay, so you've got this yield performance that's matching CAN, but lower levels of nitrous oxide emissions. And I suppose just to touch on what might be driving some of this, I suppose what we've seen in the published work so far to date is that under conditions favoring denitrification, nitrate seems to be a strong driver of nitrous oxide emissions through this denitrification loss pathway. This is work published by Niharika Raman back a number of years ago and what we saw was that the emission factor for a nitrate-only fertilizer was higher than from an ammonia fertilizer. Indeed, there was about a 66% reduction from the ammonium fertilizer comparing to the nitrate fertilizer. However, it didn't matter which form of nitrogen you provided in terms of yield, they both grew the same level of yield, around 12 tons. So I suppose, what does this mean in practice? It gives us an indication that fertilizers with higher ammonium levels and lower nitrate levels would tend to have lower emissions of the greenhouse gas nitrous oxide under conditions that favor denitrification. And there's been some work published by Gabrielle Michael that gives, I suppose, that indication. Something like 10-10-20, you've very little nitrate in that product. So that's going to be, I suppose, particularly erring towards the high ammonium side. But even something like 18-6-12, has more ammonium than it has nitrate in it. So that could potentially be also a benefit that brings you at least a little bit in the right direction in terms of reducing emissions. And obviously, as we talked at the beginning, getting in phosphorus and potassium is also really important to get the most out of your nitrogen. And many of you may be going out applying these type of fertilizers in the coming weeks. Okay, so if we look at, I suppose the last area just to touch on is, this other class of inhibitors. These are called nitrification inhibitors. And I showed you earlier how these can slow down that, conversion of ammonium to nitrate. In work that we've done previously and published, we saw that adding a nitrification inhibitor to urease inhibitor, NDPT, further reduce nitrous oxide emissions to levels that were very close to the background. So there are options there for a given amount of nitrogen fertilizer to get the emissions of nitrous oxide down to very low levels, almost at levels where no nitrogen fertilizer is applied. So that's, a pretty powerful option, but there are cost implications, and I suppose the cost benefit and who's going to pick up the cost of the nitrification inhibitor is, I suppose, something that probably still has to be worked out, but it does show that there's options there. And as part of this work that we published here in 2025, we looked at a broader suite of nitrification inhibitors, including DCD, DMPP, MMP, and nitropyrin. And what we saw was, relative to standard urea, which is already emitting much lower levels of nitrous oxide compared to CAN, I suppose the insight was that you could potentially go lower by including a nitrification inhibitor. So there is, I suppose, scope on that side. And I suppose the question is going to be, what's the value of going lower? And can that be justified against whatever additional cost that might bring to a fertilizer product? But it does show that there is potential there. So I suppose just to summarize and to kind of bring us back to the start, I think we have to, at this time is a really good time to kind of zoom in, and we're at the start of the year. Conditions have been extremely wet. It's been very hard to get out on land, but hopefully that is changing. If you start out the year saying, I want to apply lime and I'm going to start trying now for windows and get some lime ordered and get it applied, this is going to bring a lot of benefits, particularly in a high fertilizer cost year, and also giving you more potential to fix nitrogen and establish or boost clover that you already have in swards. Slurry is going out. It's going to be spread. A lot of slurry will be spread in the next month. Take advantage of less systems that you have yourself or that the contractor has available, to retain as much of that nitrogen that you already have on the farm, to grow silage and or other crops. Don't forget about optimizing pK, and particularly don't forget about sulfur for your system, sulfur for the silage ground, and a few rounds of sulfur on the grazing ground over the course of the year. I suppose solid urea products protected with NBPT plus NPPT or 2-NPT, they will protect you against ammonia loss while reducing nitrous oxide emissions. And it's important that we use as much as we can of that type of fertilizer if we want to, make progress in terms of showing emissions reductions for the sector. So that, I suppose, we don't want to lose sight of that either. But what we have seen in work that we've been doing, that liquid formulations are showing low ammonia loss while potential to reduce nitrous oxide emissions. So that potentially broadens the options there. There's potential for the nitrification inhibitors to get emissions down to levels that are close to the background. And there could be some benefits there also for reducing nitrate leaching to water. So that's an area I think that has promise for the future. But, I suppose finding the fit for it in the marketplace is probably something that's, still remains a challenge. And I suppose what I see is that there's a broadening range of products that have potential to reduce nitrous oxide emissions. Some of those are already being used on farm, and we do have that NBPT protected option there with phosphorus that's arrived, which is a new development in the space. So I suppose with that, I'll bring it to a close. I just want to acknowledge my own research team, colleagues and collaborators. A lot of people have done a lot of work, I suppose, to put together the data that I've shown here and to give us these type of insights, and the work goes on to find solutions. We're very focused on that at Johnstown Castle, finding practical solutions to address these challenges that allow us to continue production. And we've been doing that with support, funding support from the Department of Agriculture, Food and the Marine, our own Teagasc Walsh Scholarship Programme, and indeed funding from the European Union, including in the area of bio-based and recycled fertilisers, where nutrients are recaptured to, I suppose, make better use of nutrients that are already here in Ireland and in Europe. So thank you for your attention. And with this, I'd be happy to take any questions or comments.
Thanks a million, Patrick. Very comprehensive, I think. And as I mentioned at the very start, hugely timely given all that is going on at the moment. Just from my own point of view, there can sometimes be a leap of faith for advisors, consultants, or other professionals working with farmers to move from a can-based product to a protected urea type product. I'm just wondering, are there any considerations, environmental or practical, to make sure that the performance at least remains constant, that it won't impact on performance when they're used to dealing with canned products?
Yeah, I think that's a really good question. And, I suppose agriculture is quite a traditional industry, and, farmers, they're doing something for many years and they know that it works. So, trying out something new, there's maybe a little bit of a leap of faith there that they feel that they might have to make. And, I suppose they're taking the risk essentially, aren't they, if they make that leap of faith. And I suppose that's That's where the research work that we do can play a role. So testing these new options under a whole range of conditions. So for example, I showed the cutting trials that we did under a whole range of conditions, applied in all sorts of different weathers. We see similar performance. Anya's work in the grazing trials then, lends further confidence and weight to this, showing that the performance can and is being sustained. And then I suppose at a farmer level, taking up any new practice, be it use of protected urea or anything else, I suppose working your way into it. It's not always possible for every technology to go kind of halfway in, but with something like protected urea, if you haven't used it before, why not get a pallet of it, see how you get on with it. You work your way into it in that way. So that's one way, I suppose, to build up some confidence. And I suppose it is a new product potentially, so that might mean a new setting on the fertilizer spreader. Some practical issues to work through on that perspective. But it's, I suppose, a really important measure for agriculture to actually make progress in terms of showing that agriculture can reduce greenhouse gas emissions. So I suppose from that perspective, it remains a really important technology for us to make progress there. One that doesn't bring an extra cost. I see the headlines on the cost of a ton of protected urea. And I suppose it is quite a kind of a high number. But I think that the thing that farmers need to look at in the current year is what's the cost per kilogram of nutrient that you're getting. So if protected urea is costing, a certain amount per ton, a canned product is going to be costing less, but there's quite a lot less nitrogen in that product. So, can you work out what's the cost per kilo? I suppose that's the cost factor. So I won't go on any further about that, but yeah.
Okay, brilliant, Patrick. There's quite a range of questions here, and look, your research is very, very welcomed at this point in time for, I suppose, the crisis that we face on the fertilizer front and the cost of fertilizer. It's heading for €2 a kilo. Like you have given us many options where we can make savings from lime to clover to slurry. On the lime one, Patrick, what's the potential savings, or how much nitrogen can we get from our soils by getting the pH right?
Yeah, well, I suppose on the lime side of things, like it's multifaceted, the benefit, so, potentially we can see an extra 50 kilos, for example, of nitrogen being mineralized from soil where liming is done, and there's going to be a range on that. Some soils will mineralize an additional, less kilos, and some will give more kilos, but, that's not the full picture. You've also got phosphorus that's made available. So, phosphorus is the most expensive nutrient. Phosphorus is, the price of phosphorus at the moment is probably heading closer to your 380, 4 kilos, €4 a kilo. So releasing that phosphorus that you already have on farm and making it available is another really important benefit of liming. And then you've got the clover piece. So most, I suppose, reseeds that have been done in recent years, clover has to be there as part of the mix. So you've got clover out there on farms, whether I suppose you're paying, a big focus on it or not. Where you lime, you're also giving clover a bit of an extra edge, is what we've seen in it. And I suppose every kilo of nitrogen that clover brings into the picture. So you talked about, nearly €2 a kilo for, mineral fertilizer that you buy. That means that every kilo that the clover can fix and bring into the system's worth €2, and that's straight in your pocket. The more you can get clover to do on your farm. And I recognize that it's not without its challenges, but lime is helping you there as well. Yeah.
So it's multi benefits there, and especially on the nitrogen and phosphorus front in terms of trying to reduce that burden in terms of chemical fertilizer. Patrick, just some quite a range of questions here. Patrick, what is your recommendations for sulfur applied to first cut silage, and what rate?
Yeah, look, I think for sulfur for silage, you want to be getting 15 to 20 kilos of sulfur out with your first cut silage. Like what we've seen is that even where you're applying slurry, there is sulfur in slurry, but that's sulfur that is in the slurry is very poorly available to the plant. So, you're going out with your slurry application, make sure whatever partner top-up mineral fertilizer you're using has some sulfur in it. So that'd be the recommendation there. Yeah.
Okay, very good. Patrick, on the liquid and your research on the liquid nitrogen, how did it perform in terms of grass yield, the liquid N the research that you have done?
Yeah, so look at in the work that we've been doing, it's performing at least as well as calcium ammonium nitrate, and better than the standard urea. So that's what we've been seeing with it, and I think that's a reflection of the fact that for the acidified amide products, so that's like your Flex and your NXT, they are protected just because through the acidification formulation that they have, they're protected from losing ammonia gas. So that nitrogen is staying there to grow grass. And then on the liquid UAN, you've got a combination of urea, ammonium, and nitrate. So if you like, it's like urea and CAN in a liquid formulation. And again, good yield performance from it. And we have that insight from last year's work that it's also hanging on to the nitrogen. It's not losing ammonia at the same extent that you would see from standard urea.
Okay, very good. Another question, Patrick, is Tow and Fert a UAN product or a Flex N type product?
So the Tow and Fert, that takes us into that third or maybe fourth category of fertilizer that I showed there. So this is where that unit will dissolve standard granular urea, and then it's broadcasting it out, targeting a foliar application. So no, it's not a Flex product. The Flex product is acidified, whereas the Tow and Fert is a dissolved urea. And I suppose there's different kind of combinations that can be made there when that urea is dissolved. And some of those can include adding acids like humic acids or fulvic acids, for example. So that may do some level of acidification, but it kind of a very distinctly different option compared to your Flex or your NXT type products.
And have we any work in this area, Patrick, or is there any work emerging? Or
so I'm starting to do some work in that space at the moment, but I don't have any results to share at this point. But I would say that we're getting more questions on it over time. So I suppose it takes time to kind of work into these issues as they come out. But it is being used out there. Farmers are doing it. So yeah.
Okay, another question here, Patrick. Do the results differ between ryegrass and mixed species swards? And if so, how and why do they differ? Or what are the trends? Or are the trends the same? So I suppose in terms of the type of nitrogen, it's probably the same for the mixed species swards, Patrick, is it? You're using less nitrogen.
Yeah. Well, I suppose in terms of fertilizer types, well, I suppose. Yeah, that's kind of probably the first point. Like the mixed species swards, tend to apply much lower levels of nitrogen compared to, let's say, a ryegrass sward. So I suppose that's one of the benefits that they bring, and that in itself, will give you reduced levels of loss. But when you talk about fertilizer type, then the loss from something like CAN versus protected urea, it's very driven by the soil and the moisture conditions. So if you put a CAN type product into, I suppose, a wetter field or into conditions where denitrification in the soil is dominant, you're going to tend to have that loss from the CAN, be it on a ryegrass sward or a multi-species sward. But the lower levels of application can mitigate that loss somewhat.
Okay.
But I suppose similar trends, but it's a question you could go in a lot of angles with that question. Yeah.
Okay. There's quite a few questions as regards your work on the glaze, the glaze and the NBPT, and I suppose the option to put P into the mix. What's the rate, Patrick, of NBPT in the glaze?
So glaze is, I suppose, a specific patented formulation of of NBPT. And the initial work that we did looking at protecting urea and reducing those ammonia losses and values of mitigation that are used by EPA was with NBPT used at 600 to 660 ppm NBPT. And for the glaze product, I suppose like the recommendation would always be to kind of stay up at those higher levels of NBPT, because that's going to give you the highest level of reduction, which is what we want to achieve. And it's also going to have an impact on shelf life, because, it's not an on-off switch. The inhibitor degrades slowly over time. So if you put more on to start out with, everything else being equal, that has a longer period to gradually, degrade over. So I suppose glaze could be dressed at any rate that you're having yourself, right? So that would be a choice that the I suppose that the commercial company making the product would actually make. But my understanding is that glaze NBPT product had been applied at around the 600, 660 ppm level, which, in the trial work that we did, gave very strong levels of reduction. And I suppose that would be, I think that would be the ideal type of level to be at. Yeah.
Okay. And what type of products, and is it available?
Yeah, so as I think I touched on, and I focused on that particular one from the work, because that has been in the market last year. So Grassland Agro had a pro range of products with that in the market last year, and I assume that'll be in the market in the coming year. So it is something that is out there, and we have been getting questions about it for the reason that it's out there. Much like UAN is out there, it's being used. That pro range of products is out there, it's been used, and so too with the acidified amide liquid products. Yeah.
Okay, very good, Patrick. On a similar vein, Patrick, is the reduction in emissions associated with the low nitrate fertilizers accounted for currently in the inventory, as in the 10-10-20s or the 18-6-12 versus the high ends, the cut and the pasture swords? If not, when do you envisage this benefit will be accounted for?
Yeah, I think that's a good question, and I suppose it relates. I suppose the specifics of that are probably more kind of in the field of EPA to address. That accounting for what the exact emissions from every fertilizer are. So that's a process that's going on over time. And I think the piece to remember there, from, I suppose, an advice and a pointing in the direction of reducing emissions, is that, our target is to 2030, right? So, just because something might not be counted right now doesn't mean that over the next number of years that wouldn't work its way into the inventory and be backcast in terms of getting credit for it, ultimately helping us to meet our target in 2030. So I think that's the important part to recommend, or to recognize. And I suppose all we can do at Teagasc is, point towards, I suppose point out like what's the research showing in terms of options that, may give a benefit. Farmers are already doing some of these practices at the moment, and some of those practices have co-benefits. So, for example, using 18-6-12 has a co-benefit that you're applying phosphorus and potassium, and some of those products have sulfur as well, and they're needed. But look, I suppose it is a process that we're trying to provide the evidence base for new options to go into the mix. But there can be a bit of a chicken and egg situation occurring there, where we can see that something has a benefit, but it may take time for it to filter through into the inventory. But that doesn't mean that it's not having a benefit out on the ground today in practice.
I suppose the other thing we can back calculate as well, Patrick, once we have that figure, or once we have that, we can get the benefit, let's say, or the emission reduction once we have that. There's another question here, Patrick, around nitrification inhibitors. Have they been added to can type products, and is there a timeline in terms of their availability?
Well, I suppose what I can say is over the years, I have done some work in this space, and we have some current work going on in that space, looking at their addition to can type products. I suppose the timeline of their availability, that then becomes very much, I suppose, up to the fertilizer companies as to what they decide to go with and what, what pricing and what fit, etc. So yeah, I don't have a timeline on that. But what I can say is that, we've been looking at nitrification inhibitors over I suppose, at least the last decade, and they can be partnered with any, I suppose, any nitrogen form that has urea or ammonium-based nitrogen in it, and slow down that nitrification to nitrate. So, for example, you could add nitrification inhibitors to slurry, you could add them to urine patches, you could add them to urea, you could potentially add them to CAN, but you have to bear in mind that CAN already has half of its nitrogen in the nitrate form, so the nitrification inhibitor can only really work on the ammonium portion. So I suppose it needs to be able to deliver a benefit there, that's, I suppose, that probably at a commercial level gives a cost return that can be justified, or at an environmental level gives a reduction that I suppose could be engaging or going in the right direction.
Okay.
Yeah, could I just say, Patrick, there are a number of very positive comments coming in about the presentation and all of the topics that you covered. Just there's one or two things there going back to kind of the very basics, particularly with regard to pricing, and that this year is, as you mentioned, is that a very high proportion of soils are deficient or a suboptimum as regards to the nutrient status. Is that what is a very, like, let's say you're starting out, what are the first couple of steps just starting out that they should address before, obviously we're talking about nitrogen loss here, but how do they approach that from the first couple of steps?
Yeah, like I suppose, obviously there's a whole range of intensities of farms that are out on the landscape. So I suppose that's maybe the first thing to recognize. But I suppose for any given farm, maybe the first thing is, are you able to produce enough, fodder and get the best out of the nutrients that you have on your own farm, or are you relying on importing feed, etc. So I suppose first off, it's like, what's your need to grow more grass? And on some farms, there's a need to grow more grass, and then probably on some other farms, maybe they can grow enough as they are. So maybe that's the first point to start with. I suppose after that, assuming that we want to have more production on a particular farm, it's, looking at the soil samples. Usually it's not the case that the whole farm is low. So you might have fields that are high, maybe because they're close to the farmyard and the slurry tended to go out there. And then you've got fields maybe that are low and they're not giving up enough. So looking at those soil samples and saying, right, I'm going to target these few number of fields, they're on the low side. I'm going to target them with slurry. I'm going to get the slurry out there. When the contractor comes, I'm going to make sure that he uses or she uses the low emission slurry spreading so that I retain as much nutrients as I have. This is a really, I suppose, good time to be ringing up and saying, can I get a couple of loads of lime onto the farm? And can I target those to fields that are low? Or indeed, many fields could do with a shake of lime. That's another option as well. Just a shake of lime rather than, some of the most productive fields, like, could you just put out a handy rate of lime on them? We've done that at home at times where maybe you get in lime and, you've got a field that you're targeting, but maybe it doesn't need the whole truckload. And then there's a bit over and you just send the spreader off onto a productive field that is maybe, it's been a few years since it's gotten lime, and you maybe put 3/4 of a ton or a ton of lime out on it, and that uses up the load. So there's different ways to approach it there. And I suppose after that, then it's like, what sort of budget do you have there to purchase fertilizer in the coming year and getting the best mix of nitrogen fertilizer, and also looking around you as to what's available. So like what's available out there in the local economy. Like, do you have farmers that around you that need to export some slurry to maybe deal with stocking rate issues? Can you take in some of that slurry? There's a lot of dairy processing sludge being produced. That's a very good source of phosphorus, and we've been doing some work with that over time. That all needs to find a home. So you might be a good opportunity there to boost up phosphorus if you have low phosphorus levels by taking in some of that material. So there's kind of a range of options there, and obviously getting clover into the sward is I suppose something that we need to refocus on. And I suppose every time the fertilizer spikes, we tend to kind of maybe look more in that direction. It's just how do we kind of sustain that progress over time is important. And there's a management piece there. There's no doubt.
Yeah, that's great. Thanks, Mark. We have time for another couple, I think, before we finish.
There's a question here, Patrick. I don't know whether you'd have the answer to it, but it's around, I suppose, the increasing cost of nitrogen and I suppose the break-even point. Like the way you showed the response curve there, that once you go up into that flat part of the curve, like I know we have done the figures in the past, but do you want to comment on that, Patrick, with increasing fertilizer cost and the impact then on the fertilizer rate?
Yeah, that's a good question, I suppose, around the economics of it. I suppose the starting point is that, the grazed grass that we grow ourselves tends to be an awful lot cheaper than imported concentrate feed. So, so that's part of that, economic piece. So, I suppose that regardless of what the crop is or grass, there tends to be a range that the response to nitrogen is fairly linear, and then it starts to reduce or tail off over time. And that means that, the marginal benefit from that additional nitrogen is reducing up at those higher levels of nitrogen. So I suppose for farmers that are applying maybe the highest rates of nitrogen, there is a fall off in the economics of that for the topmost nitrogen. But that being said, that I suppose that additional cost or poorer return may still be economic because it's more attractive price wise than buying in concentrate feed or having to go out and take extra land. So I suppose that is in the mix. So that economics piece is going to depend a little bit on the farm and the farm system.
Very good. And I suppose there's the whole efficiency, piece as well in terms of the timing and the rate and, soil temperatures. And, as we move into later into March, into April, the efficiency of the nitrogen increases as well. So, that I suppose helps, especially with the rising cost of fertilizer, that we try to be more focused on using the nitrogen as efficiently as possible. As Cian was saying, Patrick, there's a lot of very positive comments here, and people are thanking you for your presentation. It's very timely for the update at this point in time. So I think that's it on my side, Cian, here in terms of the questions.
Yeah, that's great. Thanks a million, Mark. So we'll try to wrap things up. So I'd just like to say thanks a million to Dr. Forrestal, obviously, for his time and his contribution and answering those questions this morning. Lots and lots of interest in this topic, as you can imagine. Also to Mark for assisting with that, and to the whole Signpost team in the background that enable this to run on a weekly basis. Next week, we'll have Emily Roscombe with us, and she'll be talking about feed additives and methane production. So we really hope you can join us there. Hope to see you next week.
You've been listening to the podcast version of the Teagasc Signpost Series, the weekly webinar that promotes and examines sustainability in Irish farming. Don't forget to join us live every Friday morning for our latest webinar. For more, visit teagasc.ie. And you can also rate, review, and subscribe to the Signpost Series on Apple Podcasts, Spotify, or wherever you get your podcasts from. I'm Mark Gibson, and thanks for listening.